Yeah, our talk had a couple of name changes throughout its development as well. Which is the button to change slides? Just out of... Oh, there's a keyboard in front of me. All right. All right. Hello, good afternoon, and wow, a lot of you stayed. My presentation is given behalf on the colleagues of mine at the Induced Seismicity Consortium at USC. And it's an analysis basically of oilfield operations and seismic activity in California. It's broken down into two parts. The first is a spatiotemporal investigation of hydraulic fracturing and seismicity. And the second was a switch to looking at fluid injection seismicity, and specifically the effects of rate changes and change in subsurface pressure. So for our work, the data sources that we used were entirely public record. With the well and the well informations was taken from the California Department of Oil, Gas, and Geothermal Resources. The majority of the well operations, especially for hydraulic fracturing, that we investigated were around here in the districts. I can't read. That's what it is. But regardless, it was around Bakersfield in the LA Basin. The reason being because that's where the vast majority of them are. The seismic information came from the Southern California Seismic Network, and with the one upshot of that being the magnitude of completeness of the data after 1981 being reported at about magnitude 1.8, as was very well described by my previous colleague. Again, the basis of the spatiotemporal analysis was the ever-popular Davis and Froelich. I think I'll resist the urge to go down line by line, but the one difference, the one we might highlight, was the first one, is the events, the first known of this earthquakes with this character in the region, because with regard to depth, this had a bit of an effect. Okay, so before going and looking into the events themselves and hydraulic fracturing, we need to figure out what we're looking for, and that is well. So the diagram here shows, it's from Fisher in 2010, and it shows the vertical migration in the Barnett Shale of hydraulic fracturing fluids for operations. And you can see the downward migration's a bit more, but the effects of hydraulic fracturing tend to be pretty effective in the near field and the reservoir, but less so in the far field. And we carried this a little bit further by using COMSOL, the simulation software, to determine what spectrum of distances from the injection point we were looking to consider. We used varied simulations, varied materials, using point sources, using longitudinal stress. As you can see here, this is actually representing 1,000 psi and pressure variation with depth. For some reason, we have this calibrated in meters. Anyway, the oil field's weird. So the loadings, regardless, the loadings that we had considered were far in excess of what you would have to worry about with hydraulic fracturing. In the end, we settled on a cutoff depth of investigation about 7 to 10 kilometers. That's a bit qualitative, depending on where it is, some other things, but about relatively consistent with Davis and Froelich, at least in the spirit of it. Okay. The result of our hydraulic fracturing correlation study was, well, it's kind of described here. On the left side, you see seismic events and the stars representing hydraulic fracturing operations. And here's with a 10-kilometer cutoff. Most of them go away. So following that, again, we reviewed 840 hydraulic fracturing events from 2000 to 2013. There was not really anything to speak of in terms of a correlation, but then again, as a previous colleague commented with regard to the coverage in the Central Valley, and that's a possibility that some of them may have been missed. Well, we didn't see, at any rate, that's beyond the scope of this. moving on to fluid injection seismicity, which has been covered again. This is a plot from Bulgaria. I'm going to slaughter this. Bulgaria and Bizaria earlier this year. But basically, the point of this it's one of the better graphs that I've seen, representing pore pressure diffusion from fluid injection and showing that it has a far reach over time. At any rate, the larger volumes injected at the lower pressures tend to be more effective in causing earthquakes, at least in past experience. All right, so our study area for the second part, again, you're dealing with a lot of data, was the LA Basin, and more specifically, we actually zoomed in to mostly around the Beverly Hills oil field. The reason being because we happened to find a match. There were from 25 injectors available in this area. We happened to choose 5 owing to their proximity to a few seismic events that met our other criteria. And then from that, can this be taken out? We used event depth and well cluster proximity to discriminate potential events of interest. Here what we have circled are possible connections because they tend to correlate with rate changes. At least that's what a cutoff was for any sort of investigation. Again, the magnitude of completeness, and here we have the change in the rate change. And you start to see a few other things here as well. That really what you see more than anything else is that we need to increase lower the magnitude of completeness. At any rate, it gave us something to start from. Okay, so the next part of this would be to use a pressure front investigation by means of a reservoir simulation, which the effect of determining the fluid injections and investigating the pressure front propagation throughout the reservoir. This is rather commonplace in petroleum engineering and typically governed by these equations here, known as the black oil equations. It's basically an application of a finite volume method to solve the differential equation and determine the pressure characteristics as well as for in our case usually the quantity of the reservoir in each particular cell that is oil, water, or gas, and can be modified a bit as well. Here next we see a bit of a demonstrative example. This is a demonstrative, a bit simplistic example of pressure front propagation. Here we see the injection volumes that we took from here were from the actual data, and just simulated the effect over time. You can just take it from the reporting data. The reservoir environment can be adjusted to reflect what the actual geology is, as well as also models for geomechanics geomechanic effects can be integrated, as was shown by the paper earlier, I believe this year, by Juanes and Xu and Juanes with PyLith. Actually, with the advance of the interest in low permeability shales, geomechanical modeling and coupling with reservoir simulation has hit the ground in a rather big way, and there are plenty of spillover effects we intend to incorporate with this. At any rate, here are some diffusion curves that we have from just the one study. We're using the 1 megapascal threshold that was suggested by Dr. McGarr. The pressure curves pretty much show what you would expect, that you'd have the increased lag time and declining maximum pressure with distance. And a few other general comments. The reservoir boundaries are not always intuitive. Another way of dealing with this sometimes is rate transient analysis, and that would be something that would be interesting to use with regard to injection data if you could get data that has precision enough to do it. Especially if you were to have downhole monitoring pressure sensors or such. Also, it's a complex system, which means you have influences from several from injector and producer wells. It makes it interesting for one, and also we have plenty of analogs within the reservoir engineering world. But again, the precision of the input data might be the biggest hurdle we're running into. Okay, in conclusion. We didn't see any real correlation with seismicity for hydraulic fracturing activities. And again, the fluid injection and disposal shown to contribute to induced seismicity. Simulation of injection activities and the change of the reservoir pressure can help in identifying of which wells might be of seismic interest and might not. Our net flow, the injection production, can be considered as a better criteria for the study, and also the delta P for the activation is going to vary with the depth of event, and the study needs further investigation for efficient study. All right, and with that.